So, we are doing the problem that is based upon this concept. That is, this problem, as we told, that two blocks of mass A and B, two blocks of mass A and B, and this is basically, it is being told that two blocks of mass A and B are connected by a string and a spring. That is the most important part. So they are connected by string or and a spring. So first of all, you have to understand that, children, that this particular block which is being connected, so what will it experience first? It will experience this type of forces. So let me just draw the forces for you. Say one important force that will be experienced is the gravitational force, right? So that means it will, this is the weight of the body, it will act like this. And another very important thing is that over here there will be a normal reaction, right? So there will be a normal reaction. So the normal reaction will be act in this upward direction. And the frictional force, children, will be acting in the direction opposite to this. So what can I write down from here, children? That is, this is your normal reaction, this is your mg, and this will be your frictional force. So apart from that, there will be a tension over here, and due to this, there will be also a tension in the spring. So let me take this tension to be T, and this particular mass or this particular body will be attracted in the downward direction by the force that is equals to m into g. So these are all the forces that are active. So they have asked us to find out, first of all, initially, the mass of block B. That was our first question. Calculate the mass of block B. So how to do that? First of all, if I consider, let the mass of block B equal to m. So I have taken this as my m. And what is the mass of block A? I think they have already mentioned to us. That is, mass of block A is equals to 2 kg. So I can write easily 2 into g, right? So if the mass of the block is m, so I can write that the reaction, that is the normal reaction, is equals to m into g. Therefore, frictional force will be equals to mu into Rn. So that is equals to mu into m into g. So this is your frictional force. So children, this frictional force will be equal to the tension. So I can obviously write under equilibrium, tension is equals to mu mg. Now in this case, another important thing that you can see, children, that this tension is also equal to 2g. So I can write that this is our first equation, that is tension equals to mu mg, and this tension which is acting in the upward direction is also equal to 2g. So from here I can say tension is equal to 2g. So this is your equation. So combine these two. So what will happen? From equation 1 and equation 2, that is equals to how much? From equation 1 and from equation 2. What shall I get, children? We'll get from equation 1 and 2, that is tension T is equals to mu into mg, that is equals to 2 into g. So mu equals to mg, and that is equals to 2 into g. Am I clear to everyone? So this is equals to 2 into. So from here I get g and g gets cancelled. And what is the coefficient of friction they have given? Coefficient of friction they have given as 0.2. So I'll write 0.2 into m, and that is equals to 2. So children, m equals to therefore 2 by 0.2, that is equals to 10 kg. So the mass of B, mass of block B, so we can easily write mass of block B is equal to 10 kg. So this is the first part of the problem I have done. So next we move on to the another important part, that is they have asked us what is the spring potential energy. So what is the spring potential energy of the system? Now children, you can see over here that the tension that is experienced by this particular body. So that tension is equal to how much? That tension also is equal to 2G. And due to that, this particular tension, this body will be actually experiencing what? This body will be experiencing a force. And that force will be counterbalanced by the restoring force within the spring. So what can I say? So from here, we can obviously say that you know that restoring force in this case will be equal to what? Restoring force will be equals to M into that is tension, that will be equals to M into G, and that will be equals to M means their mass of A into G, and that is equals to K into X, because you know that for a spring restoring force equals to K into X. So what can I write, children? That K into X equals to Ma into G. Now what is the mass is given? You have already seen the mass given of this particular block that was already given in your question. That mass was given to be how much? That mass was given to be, you have seen, that was already told to be 2 kg mass of block. So we can easily write, children, that is mass was given to be 2 kg. So we can easily write Kx is equal to therefore 2 into G. So into 9.8. Another important thing I like to tell you, children, this K, they have given the value to be what? The value of K is given as 1960. Purposely, probably they have given to make your calculation much more easier. So K equal to 1960 Newton per meter. So 1960 into X will be equal to 2 into 9.8. That is equals to 19.6. So therefore, X will be equal to how much? 19.6 divided by 1960. So 19.6 divided by 1960 is 1 by 100 meter. So what is the spring potential energy then, children? Therefore, the spring potential energy will be equals to half K x square. So that will be equals to half into what was the value of K that was given to us? The value of K was given to be 1960 into x square means 1 by 100 whole square. So what we will get the answer as? Half into 1960 into 1 by 1, 2, 3, 4. So this will get cancelled. So this will be your 98. So this will be equal to 0.98 means 0.098. So I can write like this. So because 98 by 1000, right? So it is 98 by 1000. So we can easily write the answer to be 98 by 1000, and that will be equals to, children, 0.098 joules. So this is the conception. I think everybody has understood. So this is how you have to
Yes, sir.
do this